this is recurrence relations within context. We're going to look through this example. This is the type of example that comes up very often in the higher course. You have a lock which contains 16 tonnes of toxic waste, so this is your initial amount. You know that tidal action removes 15% of the waste each week, so that's going to be 100 subtract 15 over 100 to be 0.85, so that will be our multiplier. We know that a local factory discharges a further 6 tonnes of waste into the lock at the end of each week. So essentially what's happening there is you're having 6 tonnes added on every single week. So when you write your recurrence relation for part A, you're going to be doing un plus 1 equals 0.85 un plus 6, where u0 equals 16. So let me just talk about where you're getting these things from. Un plus 1 is your next term. So in this context, that means next week, equals 0.85. That's coming from the 15% that's been removed. You're doing 100 subtract 15 over 100, giving you 0.85, times by how much you've got this week, un, your current week for waste, and then plus 6, because the factory is adding on 6 tonnes of waste at the end of each week. And what's important in this example is you include the initial amount, because that's going to have an impact. Your initial amount here is going to be 16. Okay, so your initial amount of waste is going to be 16, and you need to write u0 equals 16. So let's now find u1 through to u4. If u0 equals 16, we can substitute that into the recurrence relation, giving me 19.6. We can then substitute 19.6 in, we can substitute 22.66 in, etc, etc. Now, this process you've been covering for the last week. If you're not sure of it, please make sure you're asking questions. The easiest way for you to do this is to type in 16 into your calculator, pushing equal sign, clear your screen, then type in 0.85 times answer plus 6. If you do that, you should just be able to push the equal sign several times to get the answers here. So that should be the easiest way for you to do it. Or you can do what I've got here and just lay it all out and do all the work and then type it in separately, but it's up to you. But definitely the easiest way is just to type in 16 equals, clear the screen, 0.85 times answer plus 6, and just keep pushing the equal sign. So that's the end of A. That's you got u0 through to u4. We're then going to look at part B, which was talking about the long-term effect. So if we look at the question, it says, what is the long-term effect of the toxic waste on the lock? If you see the phrase long-term effect, you should be thinking to find the limit. You'll either see long-term effect or is it safe after a period of time. So either of those phrases indicates you're finding a limit. Can we find the limit? Well, yes, we can, since -1 is less than 0.85 is less than 1. It's within that range of -1 to 1. So because it's 0.85, we know a limit exists. We write in our recurrence relation, un plus 1 equals 0.85 un plus 6. We replace un plus 1 and un with L, because when it reaches the limit, the previous term and the next term are going to be the limit. They're going to be the same, so we can write L and L for both of them. Now I want to eliminate the decimal. Now if I multiplied this one by 10, it would give me 8.5, which isn't enough. So in this example, we're going to multiply by 100. So for the ones that we did last time, you multiplied by 10. In this example, you're multiplying by 100 to get rid of the decimal fully. So just watch out, look at your decimal and make the decision. 0.85, that's going to need to be 100. So when you multiply by 100, L becomes 100L, 0.85 becomes 85, and 6 becomes 600. This is the most common mistake. Please remember, you've got to multiply the 6 as well by the term that you've decided, in this case 100. We then take away 85L, giving me 15L equals 600. We divide by 15, so our L equals 40. Now we don't just leave it as that, we've got to write a statement. So our statement sentence is, after a period of time, now I've put that in bold because you need to start with that. So after a period of time, the level of toxic waste within the lock will settle at 40 tonnes. And that's in bold because you need to have the word settle. So this statement here is what you'll be writing in these type of examples. After a period of time, then whatever context the question is, will settle at the value you've got for your limit. So in this case, the level of toxic waste will settle at 40 tonnes. And that's your sentence to finish this off. Now a couple of extra points just to take note of. Finding limit may appear in a non-calculator paper, so look out for words such as exact amount or exact value, so a decimal answer will not be accepted, and those examples leave your answer as a simplified fraction. And always remember to add the statement, so this will refer back to the question. So in this example it referred back to toxic waste, but the contexts will be different. In some cases it will be about bacteria, in some examples it will be about medicine, in some examples it will be about the amount of animals in a certain place. And you should also make sure you're using the word it will settle at. Okay, will settle at. If you use that, you can't really go wrong with this question. So remember to use the phrase will settle at and over a period of time, and make sure you lay out a clear sentence describing what's happening. So let's look at another example then to finish off. So a patient is administered with 20 milligrams of a drug. It dissipates at a rate of 3% per hour. Each hour the patient is given a further 15 milligrams. The drug will be ineffective if the amount in the body falls below 450 milligrams. Does the drug continue to be effective in the long term? So what we do here is we write UN plus 1 equals 0.97 UN plus 50. We write the sentence limit exists because -1 is less than 0.97 is less than 1. The reason we write this sentence is you need to make sure you're stating that you can get a limit. In this case it's because 0.97 is between -1 and 1. We can replace UN plus 1 and UN with L, getting L equals 0.97 L plus 15. Again, we can multiply this one by 100. Because it's two numbers after the decimal, we want to eliminate the decimal completely. So 100L equals 97L plus 1500, 1500. Remember to times the 15 by 100. That's the most common mistake, is to forget that. We're going to subtract 97L to get 3L equals 1500. We'll divide by 3, giving us L equals 500. Now, we've got 500 milligrams as our final answer for the limit. So, after a period of time, the amount of drug in the body settles at 500 milligrams. Therefore, the drug will be effective as 500 milligrams is greater than the critical amount of 450 milligrams. So, I've got the key phrase after a period of time. I've got the key part that it settles at 500 milligrams. And you're saying that it's effective. You're answering the question because it says, does the drug continue to be effective in the long term? So the drug will be effective in the long term, as 500 milligrams is bigger than the 450 milligrams that it can't fall below. And that is your conclusion to this question. So make sure when you're doing this, you write a clear sentence referring back to the question and stating the importance of your limit. So in this case, the limit is above the value that you don't want it to fall below. I've basically in the PDF file included 3 examples for you to look at. There is also questions in the textbook you can try. Let me know on the Teams page if you have any questions and if there's anything I can help with.